are on the starting line. The whistle is seconds away from blowing. At this moment, your body acts as a highly coordinated machine, primed for an explosive burst of action. Welcome to Yaka Digital Network video lessons. To launch you off that starting block, your brain sends a signal to what we call the movement team, the specific biological systems responsible for generating physical force. The foundation of that team is the skeletal system. This is the rigid mechanical framework of bones that supports your body weight and gives you structural integrity against gravity. If we look closely at this skeletal system diagram mapped over our runner, we can see how biology acts like physics. Take a look at the prompt on screen. Can you identify the fulcrum in the leg? Your bones act as rigid levers. In the leg, the femur and tibia provide the stiff mechanical arms necessary to transfer energy. The joint itself, the knee, is the fulcrum, or the pivot point. And the load is the actual weight of the body that needs to be moved down the track. But a framework of levers and pivots cannot move on its own. To push that load against gravity, we need an applied force. That applied force comes from the muscular system. This is the biological engine that drives the mechanical frame. By adding the muscle layers to our diagram, we see how they are structured, wrapping tightly around the bone to create an interconnected machine. The tissues bridging the muscle directly to the bone are tendons. These act as thick biological cables, anchoring the engine to the levers. It is important to know that muscles cannot push bones. They can only contract, shortening their length to pull the attached bone in a specific direction. We can observe this lever and effort mechanism outside of running too. Consider the physical work required to lift a heavy bag of posho. In this diagram of the arm lifting the bag, the elbow serves as the fulcrum. The biceps muscle contracts to create the effort, which pulls the forearm lever upward to move the load. The skeletal and muscular systems provide the mechanical capability to move, but sustaining that movement requires a continuous delivery of chemical energy to those muscles. To maintain muscular contraction, the body relies on the energy team. Muscle cells require energy to fire, and they derive that energy directly from oxygen. The first half of the energy team is the respiratory system, consisting of the airways and lungs inside the chest cavity. It acts as an air intake for drive oxygen into the body and an exhaust system for expelling carbon dioxide waste. You experience this intake process intensely during high-effort tasks. If you are climbing a steep hill in Kabale, your breathing becomes deep and labored as your body tries to pull in air. Extracting oxygen from the air is only the first step. The biological challenge is transporting that oxygen from the chest cavity directly into the working muscle tissue in your legs and arms. That distribution network is the cardiovascular system. The heart operates as a pump, forcing oxygen-rich blood to your extremities. This creates the body movement cycle. Blue lungs take in oxygen, the red heart pumps it, yellow muscles use it, and gray bones act as levers. The volume and speed of that oxygen flow directly dictate how much force your muscles can generate to pull on your bone levers. We can understand this loop by looking at the mechanics of a boda motorcycle. Your skeleton is the metal frame. Your muscles are the engine block. The cardiovascular system is the fuel line, and the respiratory system acts as the air filter and exhaust. Twisting the throttle on a boda demands more fuel to accelerate. Pushing your body to run faster increases your engine's demand for oxygen delivery. In physical education, we measure this requirement through physiological demand, the exact amount of biological work needed to execute a physical task. When you perform a low-demand activity, like taking a slow walk to the school canteen, your heart and lungs can easily supply the required oxygen. This data visualization compares the two states. On the left, a steady, slow-pulsing, low-demand state. On the right, high demand, a rapid heartbeat with fast intakes. The system maxes out. Oxygen delivery lines struggle to keep up with the rapidly firing muscles. This creates a critical threshold known as oxygen debt. The muscular engine is demanding energy faster than the respiratory intake can supply it. When you breathe heavily after a sprint, you are not simply exhausted. That heavy breathing is the mechanical evidence of your respiratory system desperately trying to pay back that oxygen debt to your cells. As your systems work at maximum capacity without enough oxygen, metabolic byproducts like lactic acid accumulate. That buildup is what causes the physical sensation of burning in your muscles. Your physical limits are dictated by the efficiency of this internal supply chain, which means to perform better, you have to upgrade the machine itself. This is where the human body differs from a mechanical motorcycle. When exposed to repeated physiological stress, biological systems adapt and upgrade themselves. During exercise, your body constantly fights to maintain homeostasis, an internal baseline of stability, keeping metrics like temperature and oxygen levels balanced. Upgrading your biology is similar to agriculture. Cultivating a piece of land repeatedly over multiple seasons creates richer, more productive soil. Regular, structured physical education does the same thing to your body through chronic adaptation. You are cultivating your cardiovascular system to become more efficient over time. This chart shows the result of adaptation: increased stroke volume. A stronger heart ejects more blood per beat. Consequently, your resting heart rate drops. A highly trained heart works less hard at rest, delaying oxygen debt during intense activity. Consistent physical activity physically reconstructs the inner architecture of your heart and lungs, expanding your limits. Understanding the engineering behind these systems gives you a strategic advantage as an athlete. It explains the biological necessity of the warm-up. You are priming the cardiovascular and respiratory team for high output, while physically oiling the tendons and joint levers to prevent mechanical failure and injury. A fully adapted, properly warmed-up biological machine handles exertion efficiently and recovers rapidly, proving the incredible capability of your internal systems. Every movement you make relies entirely on the precise synchronization of your bones, of your muscles, your lungs, and your heart. By mastering the biomechanics and respecting the oxygen demands of your body, you can train strategically to become a healthier, highly capable member of your community. For more video lessons and to access full course content, visit Yaka Digital Network at yaka.cc. Your body is the most sophisticated machine you will ever own. Understanding its engineering gives you the command over your own physical potential. Keep moving.